So in the variables in the equation table, we have a number of different columns, some of which are more important than others. So the first column is the beta column, and this shows you the coefficients that SPSS has calculated through the model. I need to explain to you what these coefficients refer to. So a logistic regression model is modeling the odds ratios. Now, if you're familiar with betting and you've ever placed a bet on a horse, you might be familiar with how odds ratios work. So I'll just explain how they work in betting, and then I'll explain how they work in a logistic regression model. If you place a bet on a horse and say the odds are 10 to 1, those odds are saying that the bookmakers believe that the horse is 10 times more likely not to win the race than it is to win the race compared to the other horses. If you were backing a very clear favourite that, say, had odds ratios of what we call odds on, where the odds are reversed, that means that the bookmakers are more convinced that the horse is going to win rather than not win the race. So we're always looking at the probability of something happening compared to the probability of something not happening. So in our model here, what the coefficients are looking at is they are looking at that for each of the categories of the variables that we've entered into the model, whether this category is more likely not to believe in climate change or that it's not happening by human activity, rather than believe that climate change is happening. Okay, so those are the odds ratios that SPSS is calculating. Now, we do actually have two versions of the odds ratios, because the actual statistical procedure that a logistic regression runs is actually, it produces the log of these odds ratios. Realize that some of you might not be familiar with logarithms, but it's just it's a very important it's a very important mathematical operation that's used in statistics. So this first value here are the log odds. That's what the coefficients of the model produce. These next three columns here are all associated with calculating the statistical significance of the log odds. We're not going to be looking at the standard error. We're not going to be using, this is the world statistic. We don't tend to use these. Simply, we're going to be looking at the significance value. So this is the p-value. And as with other p-values, we're particularly interested in p-values that are less than 0.05. If a number here, for example, as you can see, this second value here is less than 0.05, it means that that log odds is actually significant. So we're looking at something significant happening. Now the third column is, the last column is the column that you're going to be reporting in any output. And this is simply the exponential of the log odds. So these are actually the odds ratios. So these are the odds ratios that show whether for a particular category, individuals in that category are more likely to believe that climate change isn't happening compared to believing that climate change is happening. So we're just going to focus on these final two columns here, the significance and the exponential of the beta, i.e. the odds ratios. And if I was doing a table, a word table to illustrate, all I would do is just report these values here and indicate those that are significant. I don't need any of these other figures. So if you do logistic regression, you should never just cut and paste the output from SPSS. The only variables that you need to report is this final column here. So the kind of middle point of the odds ratios is 1. If you have an odds ratio of 1, that means an individual with that in that particular category is equally likely to believe that climate change isn't happening versus that it is happening. So if an exponential is very, very close to 1, it suggests that there isn't a statistically significant relationship. So let's look at our very first column here. If you remember, our very first row here. If you remember when we looked at the cross tabulations of gender and climate change, we found no statistically significant relationship between gender and climate change. One of the reasons that I wanted to include it in this model is because we've already looked at that relationship. We can see here that the log odds ratio the odds ratio is 0.933, very close to 1, which suggests that there isn't much difference between what women think is happening regarding climate change compared to what men is thinking happening regarding climate change. And sure enough, we've got a very large value for the significance. So gender is not statistically associated with belief in climate change. Our next variable is how much interest you have in politics. Now, you will see here that for each of these variables here, there's only one row of data. That is because we're only, if you remember, these are all binary variables. So what we're looking at here, we're looking at people who have very little interest in politics compared to those who have lots of interest in politics. We can see here that this is a much larger value for the odds ratio, 1.536. More importantly, we can see that this is statistically significant. The p-value is less than 0.001. So we can say that people with little or no interest in politics are more likely to believe that climate change isn't happening due to human activities, rather than it is happening due to human activities, compared to people with lots who have more interest in politics. Our next rows of data, these are for the variable age group, and here we have more than 2 categories here. So we've got 2 lines of data. You always have one less line of data than you have categories, because you always have to have a reference group. We can see here that even though we found age group was statistically significant when we looked at it through the chi-squared, by the time we start including other variables like qualifications and interest in politics, we can see that this is no longer statistically significant. Those are large values for the significance, so that none of the relationships that we see here are actually statistically significant. If we look at highest qualification, we can actually see that this has the biggest value for the odds ratios. So this illustrates that highest qualification has a bigger impact on our variable of interest compared to any other variable. And what we can see here, and the way that this has been coded, is that people with no qualifications, or at least with GCSE, are more likely to believe that climate change is not happening, or at least not happening due to human activities, rather than believe it is happening due to human activities, compared to people with higher qualifications. So we can see that qualification has a big impact. We can also see that occupational class also has a big impact. And this is interesting because we might think that there's a big overlap between occupational class and highest qualification, that those people in professional occupations are more likely to have higher qualifications. But there is never a complete overlap between occupational class and higher qualifications. And we can actually see that both of these variables are still significant, even when they're both included in the same model. Though we can see that occupational class has a slightly lower value for the odds ratio, indicating that there's less of a difference. If you remember, this is comparing people who don't have a professional occupation compared to people who do have a professional occupation. If we look at the last category here, which is the recode of political party, and if you have a look at political party in the raw data, you might find that there is a statistical relationship. But by the time we've controlled for occupation, highest qualification, and overall interest in politics, we find actually that there's no difference between political parties. So our reference category here is conservative. So it might surprise you that I think it was group 2 here. This second row here, this is for people who would vote Green or Liberal Democrats. Even though that exponential is greater than 1, actually it's not statistically significant. So we can actually find that when we control for the other variables, that actually affiliation to political party doesn't make any impact on people's views about climate change. So that is really quite a quick introduction to logistic regression. I wanted just to throw it in as an additional statistical technique for those students who might find that chi-squared is a little bit straightforward. It's the statistical technique that I've used most in my academic career. It can be extended to run far more complex models. There's a lot more that you can do with it. But if you have a survey and which is collecting data about individual characteristics, because we know there's so much interconnectivity between class, between income, between education, these kinds of variables that we're often interested in, running these kinds of logistic regression models is a really, really very valuable way of using survey data to understand human beliefs and human activity. If you do choose to do a logistic regression for this analysis, again, please try and present this data using a word table, and the only data that you actually need to report in your table are the full odds ratios and just indicating whether they are statistically significant or not.